Okay, concept 3 is all about using the midpoint and distance formula, but we have some vocabulary we need to do. One is the word called bisect, so make sure you have your notes out and you're filling them out as we go. And bisect means to cut a line segment into two congruent, and remember congruent means equal, segments. So if I have this line here, AB, and I'd like you to write this on your notes, and I cut it in half with point D, and I know it's cut in half because I have little hash marks, I have bisected that line segment. The midpoint is the actual point that divides the segment into two congruent segments. Now, if I'm going too fast, you just pause your video and write down the notes you need. Please draw this line on your notes, line AB, line segment AB. And I know that point M, and I want you to put a star by this because I'm going to read this. It says point M is the midpoint of line segment AB. So line segment AM is congruent to line segment MB, and the length of line segment AM is equal to the length of line segment MB. That is how you would use your notation. But you must be very careful when you're talking about midpoint, because just because a point is between two other points, that does not make it a midpoint. All right, a segment bisector. Now we've been talking about a midpoint, but a segment bisector doesn't have to be just a point. It could be a point, a ray, a line, or a plane that bisects the segment at its midpoint. Remember, the midpoint's always a point. So a midpoint or a segment bisector bisects a segment. Now in this example, we have line segment AB, and it is cut into two congruent pieces by a line, DC, creating the midpoint M. So line CD is a segment bisector of segment AB. And when we do our construction, we're going to be bisecting a line segment with a line. I know these two are congruent because of the hash marks. Now, we have a formula. When we have a line segment, and I'm given two endpoints that are coordinates, x1, y1, x2, y2 of a line segment, as I have shown here, and I'd like you to draw this on your notes, the midpoint of that segment can be found by using this formula. So basically, I'm going to add my x values, divide by 2, to find the x value of my midpoint, add my y values, divide by 2, to find the y value of my midpoint. So let's try this. Say that I have the endpoints of a line segment RS, and they are 1, -3, and 4, 2. I want to find the coordinates of the midpoint M. Well, I can kind of guess by looking at my graph here, but to be exact, I would need to use my formula. Let's just call one of my points x1, y1, and the other point x2, y2. So I'm going to add my two x values together and divide by 2. And that would be 1 and 4 divided by 2 is going to give me 2.5, which is going to be the x value of my midpoint. To find my y value of my midpoint, I'm going to add my y values together and divide by 2. So -3 plus 2 divided by 2 is going to give me -1/2. So the coordinates of the midpoint of this particular line segment is going to be 2.5 and -1/2. Well, if I'm looking at my graph, that looks about right. I went over 2.5 and then I went down 1.5. So you can use the midpoint formula to find midpoints. Now, what if I have something like this, where I already know the midpoint of segment JK, and that is 2, 1. And I know one of the endpoints is J, which is 1, 4, but I don't know what the other endpoint K is. Now, obviously, I've got a graph here, and I can just look at it, but what if I didn't have that graph? What if I didn't know what that endpoint was, and all they've given me are these coordinates? Well, I would like you to do this. I would like you to write your known endpoint, and then give a little space, write your midpoint, and then give a little more space and write your unknown endpoint with blanks. Now, would you agree that your midpoint has to be right smack dab in the middle of these two endpoints? So, if I had to add 1 to get from this endpoint to the midpoint, wouldn't I have to add 1 to that midpoint to get to the next endpoint? And if I did that, 2 plus 1 is 3. So my other endpoint, x value, should be 3. Now let's look at our y values. How did I get from 4 to 1? Well, I would have to subtract 3. So if I know that midpoint's right in the middle, I would have to subtract 3 on the other side of it. So 1 minus 3 would give me -2. So my unknown endpoint should be 3, -2. Well, let's look at our graph. And yes, this unknown endpoint is exactly 3, -2. So this is how you would find an unknown endpoint. And I can guarantee you that's on the quiz and on the unit test. All right, now we're going to talk about distance formula. But before we do that, let's quickly look at the Pythagorean theorem. You do not have to write this down. I just want you to know where the distance formula comes from. I know if I have any right triangle, I'm going to call one leg A and one leg B, and then the long side across from the right angle is the hypotenuse. We call it C. And we can find the distance of the hypotenuse by using the Pythagorean theorem. C squared equals A squared plus B squared. Well, if I know that one point of that hypotenuse is x1, y1, and the other point is x2, y2, I can find the length of that hypotenuse using this formula. Because the length of leg A would be the difference of my y values, y2 minus y1. The length of leg B would be the difference of my x values, x2 minus x1. And I can put those two expressions in my formula. So I know that C2 equals the quantity y2 minus y1 squared plus the quantity x2 minus x1 squared. I'm just substituting them in that formula. But I don't want c squared, I want c. So I would need to take the square root of both sides to cancel off that square and just get c. So this would be the formula I could use to find that hypotenuse. Well, between any 2 points, you can always draw a right triangle. And this is where we get our distance formula from. So, given 2 endpoints, I do want you to write this down. Given 2 endpoints of a line segment, x1, y1, and x2, y2. The distance between the endpoints can be found, and remember that distance means length, using this formula. And we call this the distance formula. You are going to need to memorize this formula, but at the same time, if you forget it, I'll give it to you, always. Okay, so now let's use this distance formula. Your school is 4 miles east and 1 mile, or is 4 miles east and 1 mile south of your house. A recycling center where your class is going on a field trip is 2 miles east and 3 miles north of your house. Estimate the difference between the recycling center and your school. Well, I put this on a coordinate plane so you can kind of think it through. And if you think of the origin as your house, and these 2 places as points on a coordinate plane, you could actually use your distance formula, because you could make a right triangle between those 2 points. So let's just call one of our points x1, y1 and the other point x2, y2. And when you do that, you're going to take your x values and you're going to subtract them and square them. Then you're going to take your y values, you're going to subtract them and square them, and then you're going to take the square root of the whole thing. Then you're just going to use your calculator and come up with the square root of 20. Now, simplest radical form of 20 is 2 square root of 5. But since this is a word problem and they want a distance, an estimated distance, we're going to actually put that in our calculator and say, hey, it's about 4.5 miles between the recycling center and my school. All right, now I'm going to ask you to do the independent practice. There is another video that goes over that if you need help with it.